All right. Hi, everyone. My name is Kristina. I am a product lead at Snorkel AI. We're a company that works with data-centric AI and helping companies build AI solutions according to their own proprietary data. So very excited to be here today and talk about large language models and private data and how you can actually take advantage of all of for enterprise NLP problems specifically. So my talk will consist of 3 sections. I'll start off by just talking about large language models in enterprise, what that even means. There's been so many advancements in the space, even in the last 6 months, that it's kind of hard to keep up with what's going on. But also some of the implementation challenges that we've seen when enterprise customers try to go in and deploy these large language models for actually a production use case and trying to get value out of it. And then we'll talk about the data-centric AI approach that I mentioned Snorkel AI works with specifically, and how you can adapt these large language models to your problems and to your data. And we'll finish up with a customer case study. I have one example that I brought with me, but definitely have more if you want to visit us at our booth 100 later, but I'll remind you again at the end. All right. So obviously in the last years, we've seen incredible progress in AI. There's so many new models, new architectures, new ways of doing AI and ML that have emerged. And you see this concentration of, especially over the last less than 12 months even, how much has happened in this space, that there's so much potential here for enterprises to start using this technology for their business and for their problems. And what's very interesting is that especially in the recent years, there's been this advancement that we call large language models, foundation models that work across modalities. Here we're focusing on text, so I'll be referring to them as large language models specifically. But it's all these super powerful models that have been trained on such large amounts of data and carry such vast knowledge that suddenly everyone is like, great, how do I apply this use case in my business? Because we've all seen our ChatGPT demos. I'm sure we've all used them, around with them, and there's just so much potential that lies there. So the next step is figuring out how do you unlock that potential? And how do you figure out what to do with it to drive value and stay competitive within your business? So the problem that we've seen with large language models is that they don't work out of the box. And this is true for most enterprise applications. There's 2 axes on this matrix that we like to look at. On the left side, you have domain complexity. So if you're dealing with a simple use case or some generic problem, maybe, the large language model will work out. We've all used, ChatGPT to help us either put together our schedule or something pretty straightforward. The model was trained on internet data, so of course it might do well on a simple problem. But as soon as the domain gets more and more complex, and I'm talking about finance, healthcare, there's a lot of private data that the model has never seen during its training, it's really going to struggle to do well on your problem just because it doesn't know your data. It doesn't know your domain. It doesn't have a deep enough understanding to do well there. And then on the bottom axis, we have the quality requirements. When you're dealing with mission-critical use cases, quality is pretty important. Accuracy matters. These are obviously use cases where a mistake can be very costly in dollar values and other kind of ethical concerns. There's so many things that come into it, actually evaluating whether you can deploy an AI solution in production. So for something that's a prototype or demo, maybe the LLM will work out of the box, probably does fine. But as soon as it comes to thinking about what can I deploy in production, what can I actually put out there, this is where development becomes required. And you can't use a GPT-4 or ChatGPT out of the box problems. Some of the common use cases, we see know your customer, credit decisioning, is all these really core mission critical use cases that truly have such a high impact on the business that you can't afford to just hook up a GPT-4 and let it run out of the box with all the challenges that kind of come with it and all the accuracy gaps it might have. So although large language models are truly a major accelerant when it comes to mission-critical enterprise AI, they really have changed the landscape of how we think about AI solutions and present so many opportunities. Enterprises still need a way to overcome 2 key challenges. The first is around accuracy. I mean, we all hear talks about hallucinations that these models have and errors that these make. I actually don't like using the word hallucinations. It's plainly an error. The model made a mistake and you need to do something about it. Hallucinations makes it sound more sweet and kind, but when you're trying to apply something in a business, an error is an error and you need to fix it. So accuracy concerns are definitely is one big gap we see. It's due to lack of domain knowledge, as I mentioned. These models are trained on billions of data points, such a vast variety of data, but most of it your business doesn't really even need. But the data that your business is interested in, it doesn't have any visibility into. And that's kind of that big gap that you see with them. There's also lack of transparency. If it makes a mistake, why does it make a mistake? What data was it trained on? Where does that come from? No one really knows, and figuring out how to fix that becomes challenging. And then biased outputs. That's also a separate discussion. These models come pre-trained. You don't really have visibility into why they might be making certain mistakes or certain assumptions in their operations. And the other big challenge that we see is around deployment. Deploying large language models in production, especially doing so within cost and governance constraints, is something that we often hear enterprise folks talk about. There's obviously infrastructure readiness on one side of how do you set that up, especially when working with our healthcare or finance customers. Often data is so private that you're dealing with, on-prem installations where you can't send data out because it's so private and there's so many constraints around that. So figuring out how do you deal with all these challenges. Also the high compute costs. Depending on the use case, GPT-4 can be pretty expensive to run in production if you're running hundreds of thousands of data points through it for inference every day. And also risk of proprietary data leaks. I mentioned that. For some companies, it's just, they can't afford to send data out because the risk is way too high the more private and the more secure the data gets that you're dealing with. So the way we think about overcoming these challenges is with data-centric AI. And it's really being able to take large language models, take everything they have to offer, but then adapt them to your use case and to your proprietary data. So in the old days, when you thought about that, okay, I'm starting an AI project, how am I gonna get it working? The old way was the model-centric development approach. You had your set of training data, and you experimented with the model. You iterated on the model architecture, you iterated on the hyperparameters, you were tweaking the architecture and figuring out which one fits your problem. But ultimately, data science would always focus on the model itself and the algorithm kind of under the hood. The training data was just a fixed input that you're testing and iterating on. But in large language models, that is no longer a sustainable approach. If you're thinking about these models that have billions of parameters, there's just no way you're going to be effective by trying to figure out which parameter to tweak where to fix the errors the model is making on your data and to get you to your accuracy requirements. So the only viable way becomes to iterate on the training data instead. These foundation models, these large language models are widely accessible. You're not really gonna win the race here by figuring out the architecture because there's so much open source technology. All these models are kind of available out there to use. That's no longer the competing factor. But the competing factor becomes your proprietary data, your company data, and being able to train that model and iterate on your data to get you the outcomes you're looking for. So that's why we're true believers that if you're talking about production-level AI applications, and more so in the world of large language models, you need to be able to develop these solutions to your tasks using your data. Foundation models, large language models, accessible to folks. Infrastructure is also becoming more and more broadly accessible. But what differentiates you is being able to get your specific data, your specific knowledge, business objectives, all your constraints, and really work through that data development layer and figure out how to put all of that together to build a solution that helps you differentiate in your business. And this is really where Snorkel operates. This is where we fit in and where we believe we can drive value across, whether it's predictive AI, generative AI, no matter the application, the data really becomes the core piece that you're working with when you're trying to develop and fine-tune these solutions to your business. So our company has actually been doing research around the data-centric AI area for over 8 years already. Our company was started in the Stanford AI Lab, where our co-founders were conducting research for a long time before the company even came about. But they really pioneered the programmatic labeling approach, which also becomes very interesting when you're talking about, well, great, data development. Do I need to now manually label thousands and thousands of data points, which is obviously very unsustainable. So that's where Snorkel comes in, and we really pioneered this programmatic labeling approach. How do you save time? How do you annotate huge data sets within a matter of hours, essentially, and then use large language models in the loop and the human in the loop and really get to the outcomes you're looking for? And when we think about those kinds of use cases that really come into play, it's really around how do we help enterprises to grab their data, grab their knowledge, and then that into domain-specific applications. So really going from, in the world of LLMs, from those generalist models, specialist model that applies to you. And we work with varying input data types, so we're focusing today on NLP. We also have a product for image beta that is coming out soon. But when it comes to text documents, there's a variety as well. You can have web data, you can have conversational data. There's also native PDFs and documents, just so many data sources that carry unstructured data that lie within your business and are waiting there to be unlocked and to be put to use. And we operate across various ML tasks, be it, classification, extraction, relation extraction. There's a lot of different ways to put that data to use. And ultimately, the key is it's really applicable across industries. And we've shown that, through our research, through our work with customers, that data-centric approach is truly horizontal, and it works no matter which vertical you kind of put it to use. And so the way the platform works is it has this inner loop of this guided iteration, as we call it, but then also supports all the various integrations around it to help you bring in your knowledge, your models into the platform, and then get it out for deployment and actually running inference within your process. And what we've seen our customers be able to do is really develop AI solutions 10 to 100 times faster with that approach. So the way it works is the first step is you're defining your task. You're trying to figure out, okay, where am I trying to use AI in my business, in my org? You're defining your task, you're connecting your data, wherever it might be, whatever that data might be, and you're selecting your model. So if you don't want to use a large language model, you technically don't have to. We're talking about them today because we're just seeing so much excitement about them, and there's definitely so much potential to be unlocked. So you have the opportunity to then bring in a large language model together with your data into the platform. The next step would then be to see how does that model actually do on my data. It's really benchmarking, right? That's the first question we're going to ask. GPT-4 seems great. How does it actually do when I'm trying to put it to use on my problem? What we offer is a model-guided error analysis tool that actually tells you, great, here's the performance you get out of the box, but then let's actually show you the errors. Let's let you evaluate what actually went wrong, where did the model make a mistake, and that way you're able to really pinpoint the errors the model is making and start understanding where it's failing and where is it actually going wrong. Coming back to that transparency piece that we've seen missing with just GPT or any other model out of the box. And what you're then able to do is actually correct these errors. So the programmatic labeling approach that I mentioned that we've pioneered, prompting, any other knowledge source, you might want to bring in some subject matter experts to help you understand how do we actually make sure the model doesn't fail here? Is it actually an error? How do we solve this? And then that way, by iterating on your data, you're able to go through that loop, correct your errors, retrain the model, see where it's now making errors, and really you're iterating on the data instead of having to go into the model and tweak, the billion hyperparameters. You can still do that if you want to, but the data piece is really what's going to help it stand out. And the way we do this correction piece, I mentioned we allow you to bring all the kind of knowledge sources into it. There's domain expert heuristics, there's prompts, there's ontologies, there's embeddings. We have a wide variety of that we offer to be able to actually programmatically label that data and correct the errors that it's making. And you can get very, very specific for very specific data points and data buckets to make sure that the model no longer makes a mistake on them. And what's very exciting, because the question we always get is, well, if you have so many sources, what if there's conflicting labels? How do you handle that? Because sometimes even humans have conflicting annotations when they do it. So Snorkel actually has a dedicated label model that we've also pioneered and learned to be able to take all that feedback and actually make decisions on what the label should actually be. And there's full transparency in that process, but you ultimately don't have to review every single data point with conflicting labels because we already make a suggestion on, hey, we think that's the label. And then coming back to identifying your errors, you can decide if that was the right decision or not and go from there. And then the last step is deployment. You have your model, you were able to hit the F1 score, the accuracy that you were looking for, and you can bring that out and deploy it in your pipeline. The options we offer is to bring out high quality training data, just if you want to export that data set, train your model elsewhere. But we also allow our customers to fine-tune models within our platform. And that can be a large language model. If you want to fine-tune GPT-4 directly, retrain it on your data, that's one option. But what we see a lot of customers be interested in, kind of coming back to that second challenge around deployment, is being able to use large language models as an input, as a knowledge input source, but ultimately train a smaller model as a result, because they're often expensive to run and it's often hard to deploy them. So I want to talk about these two different ways of being able to actually put the, I guess, large language models to use and to deploy them. The first one is adaptation. So what you're doing here, you're basically using GPT-3 fine-tuning API in your fine-tuning and deploying the large language model directly. So the benefits you get here is, you're still able to have that specialized model trained on your private data, and you're also able to validate the performance, making sure that generalist model was adapted to your task and it's doing what you want it to do. But the downside is you're still, in the end, deploying that large language model, which, for some customers might work. They might say, hey, we're ready, cost isn't an issue, governance isn't an issue, we just want to deploy GPT as is. But for other customers, it becomes more of a concern. And they really need to figure out, okay, how do we go around all the model management, risk management situations, and how do we handle the cost? So that's where that second path comes in, and we call it distillation. And that's really being able to use something like a GPT-4 for labeling, say, a burp model that you're ultimately going to deploy. So you're taking that knowledge that the large language model has, you're kind of extracting whatever is relevant to your business. Remember when I said most of the data the model is trained on is not really relevant to you? That way you're able to extract what is, and ultimately train a smaller model. So you have your lower cost, faster inference, improved efficiency, and ultimately an easier deployment as well to all these other advantages. And this is just an overview kind of the UI that we offer for both adaptation and distillation paths. And let's talk about the customer case study now, the exciting stuff. So I mentioned we've done a lot of research in the space. We've also started already working with customers on actually validating this. The use case I have here is about a Fortune 500 pharma company. I mentioned we have other companies that we've worked with as well in the finance space, in other healthcare companies. So definitely come by our booth if you want to learn more. But here the problem was there was a pharma company and they tried to use GPT-4 out of the box. And their task was being able to extract information from clinical studies. It was obviously very domain specific and pretty complex because you needed to understand the patient group, the outcome, and the relationship. So it definitely got very technical. And they got 66% out of the box with GPT-4, which doesn't seem too bad. But when you're a clinical trial or you're a pharma company working with clinical trials, you can't really afford to make that big of a margin of error. So when they brought it into Snorkel Flow, within hours, they were able to add some additional labeling functions, bring in additional knowledge on top of that baseline, and get to 88% accuracy within hours, which is already a huge jump in performance and got them much closer to where they were looking to be. And the way that we really did that was, first of all, model-guided error analysis. We talked about that, actually being to understand what's going wrong with my model. Where is it failing? What step do I even take next? You don't no longer have to go looking because it's all right there for you. You understand where the buckets of errors are, and you understand where to even spend your time to make sure you get the biggest bang for the buck in terms of actually improving your accuracy. Programmatic labeling, being able to use foundation models, BioBERT, SciBERT, ontologies to actually bring it in and label your data without having an SME or subject matter expert annotate every single document. And then this was actually a smaller end model. I think this was even a logistic regression model, which is crazy, that ended up performing better than a GPT-4, just through that process of data-centric iteration. All right, that is all from me. I am happy, and my team is happy to keep talking data-centric AI all day today and tomorrow, so come find us at booth 100. Use the code word Dr. Bubbles, which is our cute little mascot, and you'll also get a hat at our stand. So thank you very much, and come find us for more questions.